subtraction. Alright, so if we're going to add and subtract matrices, the big thing you have to understand is to add and subtract, they have to be the same size. So if you have a 3 by 2, you have to be adding or subtracting a 3 by 2. If you have a 1 by 2, you have to add or subtract a 1 by 2. You cannot add or subtract matrices of different sizes, different orders, okay? So, they have to be the exact same size, and all you're gonna do is do just what we did before. You know how you just took the 6 and put it to every single number? Here, you're just gonna line up the ones that match. It's the same basic concept. So the 2 here would get added to the -1 here, and you would get 1. 0 plus 9 is 9. -3 plus 2 is -1. -5 plus 10 is 5. 1 minus 7 is -6. 4 plus 0 is 4. The only thing you have to do is when you do subtraction, just remember that that does cause sign changes, just like it does in any other situation. Because if you do subtraction, you're doing 2 minus -1, which becomes
1
plus 1. So 2 plus 1 is 3.
Oh. What?
0 when you're doing subtraction.
Oh, yeah.
So you're doing 2 minus -1, which is 3.
Yeah.
0 minus 9, which is -9. -3 minus 2, which is -5. Does this make sense?
Yeah,
It does.
You just subtract matching terms. So 1, 1 was
So
1.
we gotta do both, like add and subtract?
You do whichever one is asked for.
Oh, okay. That's fine. Okay.
So if you look at the first one, I'm asking you clearly for which type.
Add.
Addition.
I'm asking you for addition. So you're just going to line up the terms. If you really want to see this written out, so that you can see what's going on, I can. You would be doing 0 plus -2. You would be doing 5 plus 3. 3 plus 5. -2 plus 7. 6 plus -9. -8 plus 6. That's what you're doing. You're taking the matched terms. So 1, 1. 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. You guys know what those numbers I just said were, right? Second row, third column. So you're just gonna add those together to get an answer, and then you're done. Yes.
So number 9, we wouldn't be able
Hold on,
to.
hold on.
We have to show that one.
Absolutely not. I do not expect you to show this work, because I know that in all reality, every single one of you can do this. 0 plus -2 is -2. 5 plus 3 is 8. 3 plus 5 is 8. -2 plus 7 is 5. 6 plus -9 is -3. And -8 plus 6 is -2. And there's your answer. Are we okay with that?
I like this so far from this year.
Okay?
So for multiplying it, you multiply the first one first, and then you subtract it, right?
If you're multiplying by just the number in the front, that means that just gets distributed to every single thing in the matrix. Just like you
In
would-
both matrices, or just in the, for number 10?
just whichever one is it's in front of. If there were parentheses around this whole thing, then yes, it would go to both, but there's not, so. Alright, now how about number 9?
You can't do
You
it.
can't do it.
Can't do it, why?
Because it's not the same
It's
size.
not the
not
same
even.
side. This is a 2 by 2, that is a 2 by 1, because they are not the exact same, that means I have nothing to line these up with.
So.
I don't have the second column,
So you just
so
do
how am I supposed to go
D
there?
and E.
You write not possible and move on.
Oh, cool.
I feel like that's gonna be something that's possible later on.
Not for addition,
It probably
subtraction.
is.
Yeah, okay, he just said it.
That's where you're gonna trick us. Multiplication.
I mean, the rules do change for multiplication between matrices, but not for addition and subtraction. Alright, so try number 10.
Okay.
Do you guys see the difference between 10 and 11 with that coefficient?
You only do it in one of the matrix, right?
Yeah, for 10, it goes to the first matrix, so you need to do that first.
Oh, the
But
other
for
one,
11,
I didn't even see the
you
front.
need to add the matrices and then multiply by 5, or by -5.
Oh.
Yeah, your answer matrix, multiply all of that by -5. Just remember, you're following PEMDAS. So in 11, you've got parentheses you need to take care of first. You don't have that in number 10, so you're looking for multiplication or division and then addition or subtraction. What do you guys get for the first matrix in number 10? Right here.
-20.
Start with, what do you get? once
Uh,
you
negative
distribute this?
10.
Hubert, go for it.
Negative 10,
Okay,
1, 2,
okay,
14, negative 6.
all right. And then I'm still subtracting the second matrix because nothing there changes. So my final answer should look like what? Taj, go for it.
-20. -6.
Okay,
20 and 18.
and then 18? Is that what you
No,
did?
not 18. Yes, 18 actually. Yeah,
Negative 6 plus 21 should give you
that's what the calculator told me, but I think it's like 50.
15. All right, so negative 10 minus 10 gave you the negative 20. 2 minus 8 is negative 6. 14 plus 6 gives you 20. And negative 6 plus 21 should give you 15. Alright, so the first thing you have to do on number 11 is to combine those matrices because they are inside parentheses. So I'm going to have the negative 5 outside still. What do I get when I combine them?
0.
0
Oh,
plus
man.
2 is
2,
2.
Oh.
And then
negative 2,
negative 2, and then
7.
7. Now what do I do?
Multiply.
Multiply by the negative 5 all the way through. So what do you get for the first term?
Negative 10.
Negative 10, then 10, then negative 35.
Is it okay if we distribute it first?
Yeah, I
For all of them,
distributed it
because that's
first.
what it is. I got the same answer, but will it work like that for everything?
And, no, that's an M.
Parentheses,
I swear I thought- oh.
Parentheses first. So you gotta simplify what's inside the parentheses whenever possible, otherwise there is a chance that it's not gonna work out to be the same. Okay,
Okay.
so, you left out, but I will tell you, most people who go to distribute this will somehow make a mistake somewhere and skip something.
I don't make mistakes in this G. I'm like shit.
You put your name out there. That's
Hey,
fine.
bro, you
All right.
not a low key no more.
Hey,
Not a wise decision.
Now, the last part is, what if I tell you that I have two matrices that are the same, but then there's pieces within the matrices that are missing, so you've got a variable or something you need to solve for.
Do you set it equal to it's opposite thing?
It's match term in the
Yeah.
other one? Yeah. So if I've got x minus 1 has to be the same as
4.
4.
So X
Oh.
is 5.
So you would set your first term here, because I have two equal matrices, has to be the same as that term. So x minus 1 has to equal 4.
X is 5.
So x is 5.
okay.
2y has to be the same as
12.
12.
Do we have to write that out?
No. My assumption is most of you can pretty easily go, oh, 2y and 12, y has to be 6.
Yeah, so can we just like fill it in?
Yeah, you can just tell me y is 6, x is 5.
And then Z is
I don't know,
8.
I feel like when the test is
Now,
gonna be like.
This is saying that z is equal to 3 plus x. This is one I'd like to see you write out, at least this step. But you know x is 5, so z then has to be,
8.
And then 9 is 9.
and then you still have the 9 equal to 9, and that's fine.
I didn't know X was 5. Oh, never mind, I lied. I wasn't paying attention.
Okay. So you've got your three variables and you're finished with this problem. Questions on that? What do you think you ought to do first for the next one?
Distribute.
Yes, I would distribute that. So you're gonna have 2x, y plus 7, z, and 4 equal to what?
Negative 10,
Negative 10,
18,
18,
negative 12,
negative 12, and
4.
well, that's nice, because now you've got your bottom, you've got a match term that you can see easily. So 2x is equal to what?
10, negative 10.
Negative 10, so x is
Negative 5.
5. Y plus 7 is equal to
18,
so y is
11,
11. And z is equal to
negative 12.
have I done anything that's absolutely shocked anyone?
Not really.
I'm okay.
I like the
Is that a
matrix.
bottom number always gonna be?
No, it could be any set, any given number.
Okay.
You might on occasion run into a matrix where it doesn't have any of them that line up, but by them telling you that the two matrices are equal, you know every single number has to be a match.
Seems pretty easy.
Alright.
Don't jinx it.
Ms. G, did you get those earrings to look like infinity signs?
We've been over this.
We did that at the beginning of class, they were a gift from another mom.
For real?
Yes.
Did she get them to look like